Hi, everybody. I'm pretty excited to be here. My name is Eduardo Solis.
Fabio Carvalho.
Carvalho. You can make a joke saying if a Mexican goes into a bar and finds a Brazilian, that's the two of us. We work for PayPal. That's the title of the presentation. I'll give you a hint. And we're actually based on beautiful, sunny, really hot Austin, Texas. The purpose of our presentation is to take you with us through our fantastic journey of modernizing Java development at PayPal. It has been a long journey to get to where we are right now. And especially in light of this conference, we want to show you what we have done for microservices, and in specific how we have adopted Spring Boot in the last release of our framework. So we work for a group in PayPal called, I think it's called now Cloud Platform and Infrastructure. We're basically part of the framework team. Our team has been responsible for bringing Java to the new era. We have one of the most successful internal frameworks of all times in Java. And just to give you an idea, here's a couple numbers. This is not Java as a whole in PayPal. This is just our sliver. Like this is the modern, the new platform. So there's about a little over 300 applications right now in production, taking traffic or processing payments. Of those, 247 are services. And when I say services, this basically means RESTful services, external and internal. There's a policy in PayPal that a service puts an API out, and it can be used outside or inside. And they have to adhere to a very tight API spec. There's about 50 batch applications that process tons and tons and tons of jobs. And there's about 32 what we call message daemons. They're actually really services. But instead of exposing RESTful APIs, they're just exposing messages. They just consume messages from different services. We have our own infrastructure. Basically, these applications today, and actually I had a different number yesterday, but the new number came late last night. This little stack is taking 5.1 billion calls per day. That's the number of hits. How do we know that? Our framework is heavily instrumented. There's a lot of metrics you can get out of it, including the number of developers that are working on it. So we have about 1,100, give or take, engineers at a given point in time working on this framework, which brings to the support. The more proprietary, the more obscure APIs that we put in this framework, the more difficult we make it to use. Works against us because we have about 1,100 guys that can come with a question and say, hey, how do I solve it? We've noticed that by sticking to things like Spring and open source projects, we can say, let me Google that for you. We send them the link, and they find their solution. So quickly, let me take you from how we're going to give the presentation. We wanted to do some live coding, but then we decided that, hey, we're going to stick just to PowerPoint, and we're developers, and we like coding. But for this one, we're just going to go with PowerPoint. I'm going to give you a history of the architecture in PayPal. There's been a lot of talks about the monolith and how to break it into microservices. I was actually pleasantly surprised in this conference to see how far we have come in PayPal into going to the microservices journey. It started a while back. So I'll give you a quick overview for that, just to give context about what are the current developer needs at PayPal. PayPal is now a polyglot stack. But what are the challenges for the overall community, and especially the Java guys? I'll introduce to our framework. It has internally it's known as Raptor for the fighter jet, not for the dinosaur. How it came to be, how we brought it in-house. And then we're going to talk about our latest Raptor release. And Fabio's going to give you an overview of how we switch it to use a Spring Boot as opposed to be an in-container Tomcat-based framework, and all the learnings from that, all the problems we had to face and how we solved them. We're going to quickly conclude with where we're going to take this framework from here, now that we're in Spring Boot and we're actually looking at this brand new ecosystem of Spring Cloud and Console and some of these other exciting technologies coming on. And then we're going to leave some time for Q&A. So let's quickly take a look at PayPal. So okay, PayPal was born in 1999. At the time, there was nothing but C++ and CGI, the emerging technology. So up to 2004, PayPal was a monolith. There were a couple of applications around this monolith, but basically it was this big, huge C++ application running in CGI, all written in C++. There's a story that somebody printed the source code and they put it out outside of one of the largest, like tallest buildings in PayPal, and it was actually like going back and forth 2 times. Was a lot of paper. They probably killed a lot of trees that day. And of course, it was not allowing the business to move at the speed that it needed. So 2007 arrives. The monolith is mostly unsustainable, and then there's these new. There are two things happen. There's something called as the. Somebody created something called the Atlas framework, which basically gives a SOA approach to development in PayPal, except that they didn't want to use SOAP. They evaluated SOAP, they didn't like it. They decided to use, I think at the time was attractive to use a binary protocol, but kind of following SOAP semantics with posts and RPC style services. But it was all C++. At the same time, another project started and said, hey, let's break this monolith into services. Let's break it into pieces now that we have the Atlas framework. And so we began our journey into distributed computing, if you want to call it. That brought a lot of new challenges that we've talked about in this conference, right? Distributed tracing. How do we know and trace how a call goes from point A to point B to point C to point D to yada yada yada? Where is the latency? How can I measure that? How can I have visibility into all of this into the system? So way back then, we started that journey. 2008, it just coincided that the first 2 frameworks for Java were introduced. There was a lot of resistance in the beginning to adopting Java because at the time the mantra was, well, C++ is fast. It's so fast that Java is really not going to cut it. It's just not. It's just slow. So there was a lot of challenges going in bringing Java to the stacks, and for that reason, it actually was brought by 2 different groups of people. There was a group that was trying to bring it to the front end and saying, hey, web applications and the Java is the choice now in the industry, outside. Let's try to do that. And they started with a fresh Spring MVC built on top of something that we inherited from eBay called the eBox environment, which was eBay in a box. It was a kind of very legacy, very old style Java programming model. So it had that going for them. Spring MVC was a first-class citizen, but at the time was all XML. It started to grow and it became a kind of a heavy framework with a lot of proprietary components to it. At the same time, in parallel, there's a service stack. This was actually built to support that proprietary protocol from the Atlas framework. We called it ASF. And it kind of looked like Axis on the top, but it was really kind of weird because it was doing this proprietary protocol. And that one didn't have Spring in the beginning. Spring was added later, but it was more like a second thought of, OK, yeah, we'll bring it so far. So they keep PayPal growing. They allow developers to start adopting Java. PayPal makes it as a mainstream language in Java, in PayPal, which was great. But in 2014, there was a decision to say, hey, it doesn't make sense that developers have to learn 2 frameworks. They don't share a core, or they kind of sort of share the core, but you basically couldn't move from one to another seamlessly. You had to learn one and then had to learn the other. There were a lot of proprietary APIs to it and a lot of proprietary tricks that you had to go and look at documentation inside PayPal. Like if you Googled it, you would get no hits because, well, they don't do the stuff that PayPal does. So there was an idea to create a unified stack with a with a more modern approach to Java. At the same time, PayPal and eBay were merging technologies. The idea was, hey, why do we have eBay labs and PayPal labs? Why don't we just have everybody combine into this one big unit, and we just produce technology for both? So this was a great opportunity for us to take the core that eBay had created, and that was already called Raptor, and we put a lot of, we changed a couple things in there to adapt to a more modern Java stack. And this is today. We're now talking microservices. We have a PaaS, this is proprietary. We are Dockerizing our environment. We can build Docker containers with applications. We actually have the notion of remote config for a while. For those of you that have been going to the Spring Cloud workshops, and you can see how you can do this remote config and the application pulls it out. We have had that for a while. It's pretty sophisticated. We're trying to adopt a more robust. We had service discovery, but it's very rudimentary. We're going to try to go with a more sophisticated solution. We have been talking about resiliency patterns. We had adopted Historics for a while now ourselves. So this is where we are. And let me talk a little bit about the developer challenges at PayPal. You're going to see it's probably the same challenges that you have in your companies. It's not unique. The PayPal developer has to be very agile. The payment space is very competitive right now. There's fierce competition with a lot of companies. PayPal is trying to innovate in a lot of different fields. So they need applications to be cranked up really quickly. Those applications need backing services. There's a lot of, the business is very aggressive on wanting results really fast. At the same time, you have these very tight deadlines to deliver these new applications, these new capabilities. But they have to have high quality, because you don't want first impressions to be bad. There's a lot of issues that happen. When PayPal gets into trouble, it's a lot of money that you lose. So there's a lot. We have very sophisticated continuous delivery, automated testing tooling around being able to figure out if we have bugs or not. We're a payments company. Security is _1 concern for us. We're one of the few companies that, since the beginning, have done SSL all the way to the back end. Most companies tend to terminate SSL in the front. We go all the way, but that's just one aspect, right? We have to deal with a lot of security, authentication, authorization, policies, a whole lot of things. On top of that, we have compliance. We have to be compliant with PCI, DSS, a lot of the payment space requirements. And it's very bad if we get out of this. We can go out of business. So it's very, very strict. We have log scrubbers. We have a lot of things that prevent PII data from being exposed. And these are things that our developers have to deal on a day-to-day basis. Maintainability of applications, but at scale. Patching an application or putting a new release, a new service that has new capabilities. At the scale that we talk about, some of the hardcore or some of the really core services, they have pools of about 500 boxes. So there's got to be a strategy. The PaaS has to be able to patch that, and not patch it in a single swipe, but have smarts, right? Like, I'm going to roll 10%. I'm going to monitor. OK, that's good. Let me go to the next 20%. And the developer is not going to be clicking the button. Can you imagine 500 boxes and you're clicking the button 500 times? So you've got to have this very sophisticated tooling. You've got to ensure that every new release or every patch that you put out there, that you keep backwards compatible APIs. There's a lot of API standardization in PayPal. It's very strict, very stringent. How we do versioning, how we roll traffic, it's a fairly complex business. And you cannot break backwards compatibility, because then you introduce failure into the rest of the system. One of the problems with microservices and distributed computing. So every application has to have great performance. We don't want to have 5,000 boxes when we can actually do the job with 200. That's pretty expensive. We got to be able to scale. We got to be able to flex up, flex down. And we got to know about resiliency patterns. What happens if the downstream services? Well, what do I do? Do I go to another service to tell, hey, stand this transaction and then recover it later? There's a lot of things that can be done, even in the payment space when services go bad. Finally, the business really wants to have visibility into these new applications that come in. How many people are hitting them? Who are they? Is this product attractive to this sector of the population? How much money is this making? Well, they have some key performance indicators that they are tracking all the time. So your application has to be instrumental with the ability to create these dashboards that give you all of these business insight into what's going on. Finally, operations. They need to know how many transactions per second are you taking, per node, per pool, PayPal as a whole. Are we seeing deviations in your SLAs? Is your performance degrading? Is your performance OK? How's your memory? How's your CPU utilization? All of that stuff. And again, developers have to provide this. So it's a lot of stuff. We don't want every developer having to worry about all of this. So by the way, there's no room for error here. I can't remember what the stat is, but I think every second is like in the order of $60,000 that get lost or more. I don't know what the exact number is. But we cannot go down. We cannot lose transactions. We have a very aggressive 99, I think it's like 4 nines. So couple seconds every here and there, our availability, we miss the goal. It affects our bonuses. So that's why in PayPal we believe in frameworks. They provide built-in support for a lot of these concerns. You don't have to worry about security the way PayPal needs to do it. You don't need to worry about certificate management, key management. They give this foundation so that the developers can actually focus on writing the products and writing the business. Our frameworks are highly instrumented. We have been doing distributed tracing. We have zipking, actually, that shows us exactly for a given transaction that, like, if you can go and say, hey, I remember that 1 year ago I had this transaction, I have this correlation ID, you can go to that system and you can still see how the flow in the system was. You can see what the latency was on every hop inside those services. Developers don't have to do anything. They just have to write their business logic. We do it for them. Another thing that we've noticed with frameworks is they give common patterns for developers to use. So, for example, let's talk about a Spring-based framework. If you know Spring, you can code in our frameworks. You can move inside PayPal. If you're one day in the risk team, you can actually go to the payments team. And you're basically using the exact same constructs. You're familiar with the technology that you're using. It's not like a mad place where you have to relearn everything every time. And overall, frameworks make life easier most of the time. So what is Raptor? Raptor is our modern Java framework stack. Again, in 2014, we set up about building it. There was a Raptor already on the eBay side. It shares a common code with our PayPal Raptor, but we decided to slide in modern design principles. When we got it, we knew it had to be cloud ready, pass ready, and it should have, it allows a DevOps model. Developers can actually deploy their own applications. They decide when they push code. They control their pools. Operations is there all the way. They're monitoring things together. There's a lot of self-service, a lot of operation and development coexistence. So what design principles we started? And this is kind of crucial of how we ended up in Spring Boot. Well, first of all, we didn't. One of the big problems that the other two frameworks, the previous frameworks had, was that they ended up using a lot of proprietary technologies. And again, that brings the problem of support, having to learn things that the industry, you bring somebody from the outside, they have this huge learning curve for these frameworks. So we decided, hey, we want to be as much standards-based as we can. And by standards-based, sure, JSRs and all of that, but also de facto standards, things like Spring. These are a couple of the ones that we picked. Some of the technologies. One of the big commitments that we have is we keep this up to date. Now we try to go to the latest release of a lot of our open source products that we use in-house. Of course, we have to have some common components, some proprietary components that are PayPal specific. We have certain technologies in the back end that they're not industry standard, and we have to adapt with them. The previous frameworks had a lot of static singleton factories, like get singleton, get sole instance methods. We decided to go with a more modern approach of a component design. We were inspired by the OSGI way of doing things that gel also very well with dependency injection from Spring. And we decided, hey, for every component that we're going to do, this is the rule. Every component has to expose its functionality through an API. The API is packaged separately from the implementation. Consumers of the component only know about the API. That allows us to switch implementations, to rev them up at different paces as long as we adhere to that API. And it has proven to be very, very clean, a very clean way to deliver our components. Even between components, they don't know about each other. They only know about their APIs. And Spring has been Spring Core has been a fabulous framework to be able to wire all those things together. As we embarked into this journey, we started becoming really good at Spring. And one of our tendencies, we're not going to have factories anymore. We're going to move a little bit from away from the design patterns from the Group of Four, that famous book. Instead, we're going to do everything through dependency injection. The production of functionality relies on the dependency injection guts. So for example, here, we're injecting a web target. For those of you that might not be familiar, web target is a standard API client for JAX-RS. This is the standard API to consume RESTful services provided by JAX-RS. For those of you that had dealt with this, you know that under the covers, you have to create a client. It's a very heavy object. You have to keep it around. From the client, you pass a route and you get the web target. So you say build target, and then you pass the base URL, and then you get it out. So we wanted to abstract all of that from our consumers. Why do they have to keep track of the clients? We can keep track of them. Actually, why do we have to keep track of them? Let's make Spring keep track of it. So we just create the client as a component. We have now interesting capabilities. At endpoint, that's a proprietary annotation. That actually happens to be a qualifier that allows us to have multiple web targets, because an application doesn't talk to one, it talks to multiple. And you can see that service name in there. What that does is actually gives us a locator inside the configuration. So you can go to your remote configuration, and you can say my service.http.request timeout. And it happens to be 200 milliseconds. Well, you can go to the remote system, and you can say, I want it now to be 500 milliseconds. Push the configuration out into production, and you don't have to restart the application. We do this with very sophisticated scope proxying, beam factory post processors to locate these injection points, and we handle everything under the cover. That's the power of Spring. It also allows us to give pluggability to our consumers. So for example, we have a way into which we like to log our transactions coming in. But the component that logs that exposes an interface through what we call a SPI. And if a customer wants to write their own, they can. They just mark their thing as a component, as a bean. You can say add component, and they say add primary. And all of a sudden, we pick that up instead of the other one, or the default one, and voila. You can plug your own logger. More interesting, we can do the same with the underlying HTTP client for the web target. Nobody does it because who wants to write a brand new HTTP client and re-instrument it? But we have the ability to swap clients on the fly. So you're still using the web target API, but you can use Apache, or you can use async HTTP client, or Finagle, or RxNetty, whatever. As long as you provide a couple APIs and you override those beans with a primary, we pick them up. You don't have to do anything. So now that we have all of this power, we started looking at, one more thing. As much as back in the 90s people loved XML, we didn't like it, we hated it. We started with a very modern Spring version, so we said zero XML. Nothing that comes from the framework requires XML. Yet, of course, for those people that care for XML and love it, we're going to let them use it. So we have component-based design, a lot of these smarts that we can do by materializing beans with Spring. And now we found a very powerful tool. We can compose this into functional profiles. And we decided to use the term profile. And a profile is nothing but a POM that brings all the components together and gives you a slice of functionality. So for example, this one says, I would like to build REST services, but I want to have all the bells and whistles to make them PayPal as a service, that's what PayPal stands for, compatible. Well, maybe you don't want to do a PayPal as a service thing. Maybe you just want a regular REST because it's internal, you don't care. There's a profile that is called REST profile PayPal. It gives you all the PayPal instrumentation, but you don't have the extra guts of security and other things that are required to survive on the PayPal side of the house. Maybe you don't want instrumentation. We have a profile called REST services. And all it does is basically using integrated RESTeasy with the framework and with all the bells and whistles, but without any PayPal license. We discovered this to be a very, very powerful. Now, for those of you that are Spring Boot, that sounds very familiar, right? But this was before we had Spring Boot. So we were already heading in that direction. Couple rules for, you can bring a profile anytime you want, but rules for ourselves was minimum to zero configuration, only really configure make the customer configure what they really need to do, like for example, a route, like we cannot discover things for them. Yet make it super flexible so that they can actually have nuts and bolts all over the place if they want to change things. And this actually proved to be very successful. We released this in 2014, I think, was the first release. Through 2015, we had great adoption, great success on deprecating the old frameworks. So we're very successful, but a couple problems start emerging. We had people that wanted to create batch jobs. Well, there's Spring Batch. Another team took it, kind of worked on it. And now we notice that the frameworks were slightly different. So now we're going back to this place where we have multiple ways of doing things, yet the same name of the framework. That's weird. We have people that just don't care about REST. They want to do messaging. Oh, and by the way, they're doing messaging. Why do they have to have Tomcat? Why are we doing a WAR file for them? They don't want that. It's just a waste. We had a group of we have a team inside the payment space that wants to innovate with some other technologies, including Cupid and LMAX disruptor. They don't want extra threads. They don't want Tomcat. They don't want to be a war. So we always kind of sort of had a soft spot for Spring Boot, and we want to take a look. And the more we went into the success of the adoption, we started noticing these problems. Our profiles, they were great, they were successful. But then we started going into some of the issues where, Maven takes you up to a certain point and gives you so much tooling, but then things that are like, hey, in the presence of this class, I really don't want to go this way, I want to go this other way. Well, you cannot do that with profiles or with add configuration beans. It's really hard. So with that, I pass it on to Fabio.
Thank you very much. So as Eduardo said so far, as he explained the history we went through since the beginning with our very first frameworks until to the moment where we had Java applications in a cloud environment. You saw that we were already able to have a very, very robust and functional solution. But at that moment, we still didn't have Spring Boot, for example. We were using Spring, but we didn't have Spring Boot. We were in cloud. We have our own proprietary PaaS solution. We were able to deliver most of the requirements we had gratefully, and especially security. We were able to monitor our applications in production, et cetera, et cetera, et cetera, right? So having said that, why would you want to go one step further, introduce a big change, take that risk, if everything seems to be okay right now, right? So as you said in the very beginning, I'm from Brazil, and there we have this huge soccer culture. And in Portuguese, we say that se o seu time está ganhando, por que você mudaria? And that means if your team is winning, why would you change it, right? Well, I don't know if you saw what happened in the last World Cup, but I am not very happy with that. So we have to go beyond, and we have to really anticipate issues. We have to be visionaries, and we have also to be smart enough to look at other people, what they are doing, and learn with that, not just with our mistakes, but with success coming from other organizations, right? And that's what we decided to do at that particular moment. Even though we were already evolving, we wanted to go beyond. And Spring Boot was not just a buzzword, but like Eduardo explained, something that was already naturally converging in our path. And we wanted to explore that. We wanted to see what that was about. But the very first thing we realized was that the solution we had in place, our framework, was already a little similar to Spring Boot. And Eduardo already touched a few of these points. So for example, the way to turn a regular application into a PayPal Raptor application was by this very initial step, which is your parent in your POM file, your Maven POM file. And that would not just bring you some dependency management, for example. It's much more than that. We already had this notion of trying to anticipate all the dependencies you would bring and avoid conflicts, etc. But more than that, like the profiles Eduardo explained, and they're very similar to Spring Boot starters, but not as powerful as Spring Boot starters. They are much more powerful Spring Boot starters. All this notion of an opinionated framework that's able to be aware of your application, the jars you have, the properties you have, and all these criteria to then automatically configure your application, we didn't have that. And of course, we were amazed to see that happening, and we wanted to take advantage of that as well. When it comes to ops and removing that gap between us and them, we already had in place many solutions for metrics and monitoring. But it was really good to see that Spring Boot and the whole Spring ecosystem also had other options that were right there, many of them even better than ours, and they came for free. I mean, in terms of maintenance, we don't have too much cost anymore, right? Since Spring Boot is already providing that. So we wanted to take advantage of all of that. And I'm not even talking about all these other great features that you all have heard about, have seen, and are probably using already, like us, right? So we want to use all of that. We want PayPal applications to use all of that. So we decided to introduce Spring Boot at PayPal. And that journey started around October last year as a proof of concept first. And now we are here, right? Well, a few more reasons to adopt Spring Boot that I wanted to share with you. So first, we wanted to have a lighter container. The whole notion of embedded container, to us, that made a lot of sense, because we were already in the cloud, and we wanted to be more and more aligned with this idea of a lighter application on microservices. And we also wanted to experiment with different containers. We didn't want to have that as another impediment or another roadblock in terms of maintaining that or even deploying that to our past solution. So we wanted the container to be there for us and do what it's supposed to do, but not at a very high price. Besides that, the same situation applies to the development experience, right? You sit in your laptop and developing an application. You also don't want to have a standalone Tomcat or whatever application server or serverless container you would have. And then you have to tie that to your IDE. And then you have that problem of synchronizing code, et cetera, et cetera, et cetera. We want simplicity, right? We want to reduce maintenance and cost. So all of that was important, besides aligning with with Spring frameworks that we were already using. We use, for example, Spring integration, Spring batch for depending on the type of application you use, and many other Spring frameworks. We also use Docker, and we are going towards a hybrid cloud solution too. So all of that made sense, and we were okay. I think it's the right decision to go this way. But it was not straightforward. It was not that easy. Maybe this is the most important information we'd like to share with you today. I don't know if you are going through something similar or not in your company. But we faced some challenges. And the very first one we realized was there was no RESTeasy Spring Boot starter available at that time. And why is that important? Well, I suppose it's very common for Spring applications to use Spring MVC or Spring Data REST, right? But we are not doing that. Maybe 2 years ago or a little over that, we decided to evaluate what would be the better way to provide REST infrastructure. And we wanted to adhere to the spec at the time, which is JAX-RS. So we evaluated a few JAX-RS implementations. Besides trying to decide the best one, we also wanted to align with that and make sure our framework would fit together with that tool, right? And the chosen one was RESTeasy for many reasons. Many reasons. We already knew SECSAT very well at that time because that's the one used by our legacy framework. And we compared with Jersey and RESTeasy. Eduardo talked about, for example, being able to plug the HTTP client behind the scenes, the one you want. We liked a lot the API RESTeasy offered. We also evaluated performance, documentation, how active the community behind the open source project was, all of that. And RESTeasy was the solution that we liked better, right? JAX-RS based. 2 years passed by, now we are going to the Spring Boot land, and there is no Spring Boot starter. So what to do? We decided then to develop a RESTeasy starter, and we did, and we open sourced that. We'll talk a little bit more about that later. Second challenge, servlet container customization. We are using Tomcat. Eduardo mentioned security, right? Very, very important requirement for PayPal applications. So we had some specific customizations we had to do at the container level, the connectors, for example. Thankfully, at that time, Tomcat had a very nice documented API that we could use. Of course, it was not a standard, had nothing to do with the servlet spec or any, it was proprietary, it was specific to Tomcat. Well, as we moved to Spring Boot, that's gone. That does not exist anymore because now Tomcat is just a jar in your application, right? As any other one. So the whole API is gone as well. That does not mean we could not address our needs. We still could, and thanks to Spring Boot, because at the low level, it also provides a very nice programmatic API so that you can customize your container. I don't know if you have used that or if you're familiar with that, but yes, it's true, and it's amazing. We could do everything we used to do before. Now we can still do. The life cycle and the phase, all of that's different. We are going to talk about that in a second, but we still could address our needs. Well, I forgot to press the button. So that's the Tomcat API, or the UML lollipop notation. I don't know if you are familiar with that. Yeah, so now talking about initialization, right? Here we have a very nice diagram. On the left side, you see before. On the right side, you see after. Before Spring Boot, after Spring Boot at PayPal frameworks. So notice that you have 4 layers right there, right? The one, let's start by the left side, the outer one, Tomcat. That used to be our container. It is still, but it was not embedded. It was a standalone regular Tomcat. Inside of it, we had our Raptor framework, the PayPal framework, Spring, and then the application. It's like a Russian doll, right? Now let's take a look at the right side. The smallest doll that does not open itself inside of all the others is the application, is still, right? But now, Tomcat is the second smallest one. You see? It inverted. And Spring is now the very first one, the biggest one outside. And Raptor is still the second. The yellow layer right there is still the second. So again, I don't know if you have gone through something similar to this in your organization, but that was a very, very important realization we had. This is something that you don't see, I don't know, I don't think you'll see when you're just developing an application, or especially an application from scratch. But if you're dealing with a whole framework that you want to offer so that business units can build the applications, this was very key. So the initialization order and who manages that is completely different now. Before, it was Tomcat, right? Now it's Spring. In Tomcat, which it's in compliance with the Servlet spec, you have this notion of a Servlet container initializer application type, an interface, right? Which happens to have this annotation called handle types. And that is triggered very, very earlier during the bootstrap of your application. And that's very powerful. Gives you a chance to do many things earlier and manage your application, right? That's gone. And we were using that with Raptor a lot. We have many components we wanted to configure and initialize before earlier. Configuration, security, et cetera, logging. All of that was completely out of place. Well, the good news, though, is that Spring is the one in that position right now, and we really trust that it was just a matter of time adjusting these building blocks to get to the same result you want. And that was the case. So we did all these modifications, and everything worked well later. Servlet container configuration. We talked about customization. Now configuration. Well, you used to have this XML file for Tomcat before. Now it's gone. Good news is Spring Boot also provides everything you need in that sense. It's either via your properties file, your application properties, or whatever it's named, or programmatically. So again, it was something we had to do, and there was no gap there. Spring Boot offered all the hooks, the integration points, the API we needed to make things smooth, especially when you think about backward compatibility, right? Eduardo mentioned that. That's very important, very, very important. You cannot introduce something that's amazing, beautiful, and new and modern if the cost to get there is too much. Or if you break, you just break, make it impossible to upgrade. Skinny jar approach. When you think about delivery, you might think, well, let's have just one jar, a fat jar, a jar that contains others. And that's the recommended way of delivering your application when you go to the documentation, right? Spring Boot documentation. we decided to do something different here. Why? Because we decided to take a look at how things happen behind the scenes. And we realized that Spring introduced this custom clause loader, and which, of course, it's great and works, etc., but brings some extra complexity. Okay? And what's the benefit of having a fat jar or executable jar if, in our case at least, in the end of the day, the developer will not really touch that? We had this pass solution, we had this deployment engine, and everything was automated. So it was like, okay, here to you, a nice feature, but its complex comes with this risk. But you're not really taking advantage of the benefits. So we decided to not do it. We decided to do it to make it simpler. We assembled that by ourselves, and we have a way to lay our files and folders and everything. But we are keeping the class loaders in the way that we want. And in the end of the day, the solution works the same. The Maven plugin Spring Boot has to run your applications is still available, works fine. In develop environment, everything's great. The IDE you have is also great to do whatever you want. We are IDE agnostic, by the way. So that's just something we wanted to mention that we also evaluated and why we chose the solution we chose, the decision we chose. JMX conflict. We had a few conflicts when it comes to JMX. We use a lot of JMX. And Spring Boot also likes JMX and tries to go one step ahead and have some JMX registrations and beans, etc., done for you automatically. That's great, but it conflicted with what we had in place. So we also had to do some modifications. But again, nothing low level, nothing scary, no. Just searching documentation, Spring Boot documentation, and everything we need to make everything happy was right there. So nothing bad here. Nanny process, yeah. We use a nanny process to make sure our application is gracefully restarted whenever necessary, etc., etc. Well, before we had a regular standalone Tomcat container. Now we don't have that anymore. We have a Java application. So was that a real problem? No, it was just something else we had to do. But nothing special, no blockers there. Logging, similar situations, more adjustments to be made. You don't have Tomcat anymore taking care of that at the low level. Again, it's a Java application. The logging changed a little bit.
Log locations had to change.
Log locations had to change. We were using SLA4j, so that was great. So that's it. Now, upgrading. It's the last one, but not the least, right? Very important. Very, very important. I don't know if you are going through the same thing we did, or if you already did that, or if you're planning to. But that item right there is something that it's hard to predict in the beginning. It's something that you don't face, you don't really feel that pain as you go through this transition. And it's something you really learn from later, at the later phase, when you finally have your first applications adopting your new framework. We are still learning, we are still improving, and we are automating our upgrade. Okay? We decided that automation was the best way to do it. A manual upgrade is not going to scale. We are writing a tool to do so, and we are hoping to open source that tool. I don't know, but maybe in the future we can talk about that, hopefully. And this is a non-Spring Boot to Spring Boot transition, right? So hopefully more people can use it and contribute and make it better, because that item there is very important. Okay, so our results in a few numbers. So our very first release was made available to our applications on April, so 4 months ago. And out of 300 Raptor applications, over 100 are already using the Spring Boot version of it, the latest version. And we already have around 200 million calls per day on Raptor and Spring Boot, out of 5 billion. You see 4.2 there, it's outdated, it's 5. It's like number from last week to this week, is that right?
Yeah.
And we got really good feedback from developers, really, really good. I don't think it's because of us necessarily, it's because of Spring Boot. It's just because of how much better experience it brings to the table, to the developer, and we want to do the same for ops later. We are still using our proprietary metrics and monitoring solutions. This is just like a first phase of how our whole transition. A next phase, we will add that. So now talking about what we had to do in terms of design. As Eduardo said, we realized that it would not be very feasible to do demos or show code or anything. But this diagram that you can see here shows a few blocks. They are starters. They are Spring Boot starters, okay? We realized that it was really, really the best thing to do, just adopt this technology. And first of all, we layered our components in these 4 different layers. Let's start by the second one, actually. At PayPal, we have 3 types of applications. It's either a REST application, a message daemon, or a batch application. Eduardo already told you about that, right? So we have 1 Spring Boot starter for each one of them, plus 2 extra for different types of flavors of applications. They are additional helpers starters, let's say this way. And then going back to the first layer, a core starter, okay, that is shared among every single Raptor application. This core starter is responsible for things like the whole framework initialization and configuration and initializing the security and all the components that you must have to define you as a Raptor application. And then the second per type. The third one and the fourth one, pretty much they are clients or drivers for external systems. The third one particularly, they are clients for downstream services you want to call, for example, or either our sole proprietary, because we still have these legacy applications, or the latest one in the newest framework. And then in the fourth layer, if you want to integrate with caching or messaging, etc., or database. All of them are starters. That means configuration now is automated. They are opinionated as well. We give some freedom for our applications actually to choose a few third-party components they want to use, and we make sure all of that's aligned. So we use a lot of those conditional annotations, and as Eduardo said, we also use programmatic ways of registering beans, et cetera, et cetera. So that was the biggest effort we had in terms of coding during this transition. And if you want, you can talk later about that in person if you want to know more details. Now, talking again about our need to have a RESTeasy Spring Boot starter. We also developed that, right? It's not in the previous diagram. It's an open source project now. And what it brings to you, well, first of all, it enables RESTeasy for Spring Boot applications. That was not possible before. It was just not possible. Now it is. In addition to that, every single one of your JAX-RS resource and providers, or even sub-resources, they can be Spring Beans. Okay? That was already possible before. RESTeasy has this Spring Boot integration. That was already possible, but we made it align together nicely with Spring Boot as well. And this is new. Now, your JAX-RS application can be found and registered nicely as a Spring Bean as well. Okay? This is something new that did not exist before. We also provide other options of registration which are more aligned with the old days, let's say this way, and the JAX-RS spec. So for example, you can do that programmatically or rely on class path scanning or just have a configuration file pointing to the class. So we have options, right? And finally, you're not missing anything. If you had a previous application that was using RESTeasy and you had all those configurations very nicely defined for you, they will be there still, okay? They will still be available for you. And if you have been using RESTeasy already, you know that they are done as servlet context initialization parameters. Well, they are still available to you in Spring Boot, even though you don't have a web XML file anymore in Spring Boot. Spring Boot has a way to define those properties in your application properties file. We are just using that. So it's all the same. The same thing you do in a regular Spring Boot application, you also do here for those properties. Here you can see just an example of what your application class would look like. So everything you do there is you just add a component annotation. Now it's a Spring Bean. And it will be available for you. Your mapping will work fine. You have a servlet behind the scenes serving your requests, etc. It's an open source project. If you want to check it out, that's the URL. You can just go to GitHub, PayPal. You see all our open source projects. We have many, and one of them is this one. And if you like it, please start our project. All right, so where we want to go now. Again, this is just the beginning. There's just so much to be done, so much to be adopted from Spring Boot, and so many lessons as well. Personally, Eduardo and I got being here and taking a look at Spring Cloud and even Cloud Foundry and all these things, talking to other folks. So the very first thing we want to do is we want to introduce this concept of Raptor Lite. So right now, if you are a PayPal developer, depending on the type of application you have, you bring this Raptor flavored framework for you, and there you go, you do whatever you want. However, we realize that that's not really, really ideal for a few situations. We have, for example, many business units, and they are so big that they have their own infrastructure teams internally. For example, risk management. Let's just mention this one, or payments. There are many, right? So they were like, okay, we want to use Raptor, but there was something, an extra layer we want to add right there to offer to our developers. And it would be better if Raptor was flexible for that, because I want to be able to have better customization. So that's what Raptor Lite is. Yeah. It's a minimal Spring Boot PayPal application. Do you want to add something, Eduardo?
And we want to allow basically the Java container. So right now we talk about, oh, you can create a service or a message daemon. What if you want to create a command line interface, but you still want to use all the PayPal infrastructure? Yeah. Well, Spring Boot's perfect for that. There's no reason why we cannot do that. So we're going to create a very minimum core that just gives you all the PayPal core, services, and then you can actually start creating on top of that.
Yeah, and that would just still give you security, for example, which is something very important. Again, we are going to start a new phase to go and take advantage of more Spring Boot stuff. And here are just a few examples of them that we are not really using yet, but we would like to. And also, this next little piece of items here, they bring technology that we already have in place. We are already using analog technologies, but we would like to evaluate other options, right? So for example, Undertow instead of Tomcat, especially for performance reasons. But we still have to evaluate and see what it takes to go there, right?
I was very excited about the keynote when they talked Spring 5 going with Reactor as the core, because it's like, oh, I don't have to work on this too much. I can probably just work on it. But we actually had that in our radar. We want to try to go into a non-servlet model for the exact same reasons that were presented in the keynote. We want to allow people to create asynchronous non-blocking services, and right now we have the servlet model that is kind of holding us back on there.
Yeah, that's great. We'll definitely take a look at that. It's Spring Cloud configuration. So like we said earlier in the talk, we already do that. We already have a remote configuration system in place, but that's proprietary. So there are two things we could do. We could just go and take advantage of Consul or the GitHub approach that Spring Boot applications have now, Or we could just do a half step, which is, OK, let's reuse the API, the configuration API that's right there, because we're not even using that. The notion of refresh scope and configuration properties annotations, and tie that to our system.
We have all of that concepts through a proprietary API. It actually uses Apache Commons configuration API, so it's not like that proprietary.
Yeah.
But it'd be great if we could actually hook up and switch and use our system with those capabilities on the back end, but still use the Spring annotations like at refresh configuration and all of that stuff. So that's something that was very interesting that I want to explore.
Yep. Service discovery, same thing. We already have a solution in place, but we were like, wow, there's so many other nice options out there, right? We had to take a look at those too. And you want to talk about the last item, Eduardo?
Yeah, we have some needs for high performance, and I think there was a talk yesterday that talked about when you have microservices and you go to what's close and dear to you, which is HTTP, not necessarily the best for multi-hop and multi-service communication, pretty slow. So we want to explore with, there was a very interesting talk about Google RPC yesterday. That looked very interesting. We're already using protobuf in some domains, so that would be kind of like a next phase. There's Aaron, which is another protocol that looks very interesting to play with. And of course, AMQP, Rabbit or Cupid. We have been playing with this. And with that?
Yep, we are open for questions.
Yes?
Just a second.
Would you mind repeating the question? The question was if in 2014 we started with backend as a service. The 2014 was modernize the Java development so we could have a microservice style architecture heading towards that. So we don't, a lot of our backend services were already following a SOA model. So there are already services, there's a service registry. We had enterprise interfaces that you have to adhere. A lot of that has this proprietary protocol, so you cannot just go and grab JAX-RS and use it. Let me quickly, so the question was, how do we do it? Do you see that box that says SOA client? That's the guy that allows us to talk to those backend services. So it still presents itself as a regular RPC, like you inject the we actually did a couple tricks there. We actually we did a sliding of that protocol on top of JAX-RS, because at the end of the day, JAX-RS is just a post and we just get data. So we use a lot of the hooks, and then we can inject the enterprise interface, which is generated, which is an annotated JAX-RS interface. We don't have a lot of SOAP-based services internally. It's more this proprietary protocol. And we had, for adoption purposes, we have actually also done the service side of it. We discourage it, but you can actually implement services of this type inside the new stack. We don't have that slide. But yeah, I mean, it's a transition. It's like what Fabio said, right? It's not just about bring the new and yay, we have to adapt to what's out there. Yeah, so it's a very good question.
Here.
Yeah, I would like to hear your experience about data model design, how this shares between microservices, and two, how you deal with transaction between these microservices, your experience.
Repeat the question. Repeat the question.
The question was, how do we deal with the data side of microservices?
It's more about the data model, how you design the data model. You have a common design that is shared by all these microservices, or you're following these ideas where the proposal is a one scheme, microservice.
Yeah. So the question is if there's one scheme, or how do we deal in the microservices world? There's a disclaimer, we're not experts in the data side of things because we're framework developers. We actually have a PayPal fellow here that might know a little bit more for his domain. It depends on which domain you're talking. I know about big moves to be able to adapt this. There's a share nothing like zone approach where you have one schema but it's actually sharded, and then we have a session affinity going in and out so that the data is actually in one.
Some people design having a microservice for pricing, the other one for order, the other one for customers, and the idea is to have one schema for customer. Like if the customer changes, how you spread the data, okay, through all the services. How you
I see what you're saying. So because we don't have distributed transactions in PayPal. We have never had. It's always been service to service. So yeah, rollback can be a bit of a challenge when something fails and then you have to undo. We follow more of an architecture of the data is hidden behind the service. The JSON schema changes as new elements are added. I'm not an expert on that, to be honest. But yeah. Sorry.
You had a second question, right? No?
well, it was more or less related.
Okay.
It's about transactions.
Transactional boundaries, yeah. The one thing I know is PayPal is against distributed transactions. We don't do, we tend not to do distributed transactions. I think the schemas seem to be like, because we have these siloed domains, the database is actually fixed to the schema is actually fixed to the domain, and then the exchange of data happens through services. It is with challenges, especially when you talk about performance and SLAs, because you got to go to multiple places to fetch data. There's some ideas around how we can fix some of that, but we're not the authoritative sources of. Yes? Excellent question. The question was, how do we deal with JDBC connections at the scale? Because we have a lot of instances, and if each of them connects to the database, we can bring it to this base. Yes, PayPal is mostly Oracle rack. We have, how would we call it? I think we could call it JDBC as a service.
Yeah, it's like a type 4 JDBC driver.
Yes. Something like that. So we have servers that are concentrators of connections. Those are the guys that connect to the database and have connection pooling. And then we have this driver to the application. It presents itself as a JDBC driver, but in reality it's not connecting to the database, it's connecting to these services.
Yep.
And it's multiplexing the connection. So it's the service really that has the connections and sessions for the database, and it's like a middle layer. It's like a level 4. I'm sorry, can you repeat that?
Bottleneck?
A bottleneck, because we have to have the extra hub. Is pretty performant, right? It's been tuned, and there's other probably PayPal talks where you can say, I think internally it's called OCC.
Yeah.
At some point, I think there was going to be some work with Oracle to kind of promote it into the industry. How it does things. It's basically a concentrator.
Yeah, and the whole idea was actually, first of all, it's distributed as well. It's not just one single host. And second, we still have many C++ applications, right? And there is a lot of connection pooling and caching and etc. that is already in place, not just for Java applications, but for C++ applications. So this extra layer that we added takes care of all the different application types.
We can talk a little bit more if you want afterwards. We have time for one more question.
You guys mentioned Cupid. We were similar to both, but Cupid still needs the effort. So you guys have plans to move away from that?
Cupid or MQP?
The question was, what is our experience with Cupid since it's going to be deprecated? It's an experimental product. The real goal is to use an AMQP 1.0 protocol. Yeah. Cupid was like the driver, and they had that reactor, actually. the Cupid Reactor, which looked interesting. That's on the payment space. Again, we're not in that division. We just work with them. And our interaction with them was a lot with, they didn't want Tomcat there because that didn't make sense. So they were one of the main drivers to validate that this work could be done. If you want, we can discuss afterwards, and I can give you some names of people that you can contact and talk.
All right. Thanks, everybody, for being here.
Thanks. We're going to hang out if you guys need one more question, some more questions from him. Thank you.